Hello students, hope you all are doing well and you all are also studying well. Welcome to this video. So today we'll be going for the new concept, we'll be studying a new concept today. So you can guess about it. So some captions I have written on the board like 50-50, then 33.33%, and some commonly said, what do you say, some commonly said things I have written like maybe, maybe not, then 99% sure about it but don't know about 0.1%. Then we have why to take chance. So these all things are related with one particular concept. So the same concept we are going to discuss today. Alright. So we'll have some examples here. Okay. So now suppose there is a team of 2 members each for a project. Okay. And only one of the member has to write the exam, or only one of the member has to you say give the presentation, and a team of 2 members is there. So you don't know which member has to write the exam. That you'll be coming to know at the time of exam itself, but only one of the members has to give the exam. In that case, how do you take up with the preparation? So in that case, you can say ultimately there is one person who is not going to write exam. So if someone who do not want to study may go for that option, but you also don't know who has to write the exam. So it can be anybody among two who has to write the exam. Now you can say both of them have the equal, what you say, chances. It's 50-50%. So it can be person A or it can be person B. So most of you or most of the teams could go for this, that they would study, both of them would study or both of them would prepare for the exam. Okay, so now in that case, it is 50-50% chance, nothing can be told who is going to write the exam. Now if there are 3 persons in a team and again it remains same that only one of them has to write the exam, then you can say that chances are little reduced, but everyone has equal chance. I mean, one of them would be, every one of them has chances is like 33.33%. Mathematically we can say that, but it is like one of them has to write. Okay, so now suppose the team is of 10 members and only one of them has to give the exam. Now in that case, you may have one of your friend or it can be you yourself who would say, it's okay, I can take a chance, I'm not going to study. I'm not going to prepare for the presentation because one of the 10 person is going to write the exam, other 9 will prepare, then it's okay if I don't prepare. So someone is ready to take a chance, though he or she is getting selected, but ready to take a chance and not to prepare. Now, why this change in the decision is happening? Because of what it is happening. So someone is ready to take a chance and someone would say, no, why to take chance? Though it is one member among 10, it can be me also. So why to take chance? It may be me or it may not be me, but there is a possibility that I might get selected for writing the exam. So this is happening why? Because the amount of what you say, getting not amount of chances, as it is going on decreasing, that decision also making some change. So you are making some changes in the decision. So when you are sure about some things are going to happen, or when you are sure about for some things possibility is really more, then for those things or any actions which are required, we do complete those actions. If we know that there are more chances this is going to happen. For example, if you by looking at the environment outside, if you know there are more chances which is going to rain, then you take the precautions which are required. If there are more chances it is sunny from the morning till afternoon and you are about to go out and you know that it is not going to rain, then that way you make the action. So it is all depending on the chances. Okay, so that's what I have written about, but it is still a chance. There is no 100% surety about it. So most of the times we talk about such things that we are 99% sure that this is going to work out, but don't know about 0.1%, or it may or it may not. Okay, so these all terms are related with one concept called as probability. So these all terms are related with this concept, our new concept called as probability. So this we are going to study in your unit 4. What do you mean by probability? The terms which are related with probability, and how do you calculate probability mathematically. Okay, so now these two examples I had given where say there are two members in a team and they have got 50-50% chances of getting selected to write the exam. So for three members it is 33.33%. If there are 10 members, then we calculate it in this way. Anyway, we are going to select only one member out of 10. So for all of them it is 0.1. Okay, and if you convert it into percentile, it is 10% chance. So each of them is having 10% chance above for it. Okay, so this is how the probability is calculated. So now we will see what are the terms which are related with probability, and also the mathematical expectation of the probability, and what kind of problems we have to solve using probability. So basically probability plays a major role in decision making, and we also see it in day-to-day life as well. So now when we have multiple factors together combined and with their probabilities, then that also makes the complex decision easier, or gives direction to the decision based on the value of the probability. Alright, so now we'll quickly have a look on the basic concepts which are required in the probability. Welcome back. So these are the concepts which I have noted here related with probability. Starting with the first one is called as random experiment. So random experiment is one statistical process which can be done repeatedly, and every time its result cannot be predicted. It is unpredictable. So that is what called as a random experiment. Okay. So now, for example, if you consider this is a chalk box, and from this I can remove any kind of chalk here. So now here I'm having all of them of the same color. So if I would have of all of them of different color, then every time I take out one chalk, it can be of any color. So there could be 5 or 6 colors, it could be of any color. So now every time I do this process, that result is not predictable. Okay, and if it is of same color, then it is every time it is going to come on obviously the white one. So considering the color concept here, this cannot be called as a random experiment. So its result is not predictable every time. That is, you need to understand. So it can be repeated multiple times, but its result is not predictable. Okay, now tossing of a coin can be a it can be a random experiment. It can be head or it can be tail. You never know, but that can be done repeatedly, and the result is unpredictable. Then also the middle one, what I have drawn is the dice. So it is called as the dice. Okay, so rolling of dice is also random experiment. Rolling of dice is also random experiment, which you people might have done many times while playing Ludo, and you expect for some number, but that possibility always goes ups and downs. You might have, so the point is here, it cannot be predicted. You cannot predict its result. So rolling of dice is the random experiment. Tossing of coin is a random experiment. Then we have the playing cards. So from the playing cards, if you remove any one of the card, it can be any card, it can be black, it can be red, it can be from the, it can be any one suit, it can be square, it can be diamond, it can be any such. So these are called as the random experiments where you are not knowing about the outcome, or you can say the result, which is not predictable at all. So these are some examples of random experiment. So here I have noted two of them, that is tossing of coin and rolling a dice. These are the random experiment. Then the next definition is event. What do you mean by event? Okay, so event is any possible outcome from the random experiment. Now, if rolling of dice is the random experiment, then getting 2 from the dice is your event. Okay, so or you can say getting even number from the dice can be also event. So event is basically what you say is the outcome from the random experiment. So if your experiment is drawing a card from the playing card kit, then if you got the red card or getting red card is also a event. If there are tickets number from 1 to 20 and you just randomly choose one, and if you get ticket number say 16, then that's a event. Okay, then there are two types, actually four types of events. Basically there are these two types we'll discuss first. One is called as the simple event and another is called as the compound event. Okay, so for event I can write the example. Even getting head, getting head when you toss a coin, that's also is event. Okay, so any such examples you can consider. Then there are two types of events, sample event and compound event. Okay, so every event from your random experiment, the every smallest event which cannot be divided further is called as the simple event. Okay, and the event which is occurring all together, which is a combination of one or more two events, is called as the compound event. So it goes very straight with the definition. Simple event is one which cannot be divided, it's alone is one event, is your simple event, and compound event which is all together, which is made up of multiple events, is your compound event. So simple events are now, if you consider the tossing or rolling of a dice, then getting 1 or getting 0.2 is a simple event. Okay. So now getting 1 you cannot divide into further any other events, or getting 2 you cannot again divide into further events. So it's a simple event. Okay. Now if you say event when you roll the dice of getting the prime number. Now here prime numbers are 2, 3, okay, and 5, and also 3 and 5 are odd. So now there are the multiples here. It is simple event as well as prime event, and two of them are odd. Okay, so this is called as the compound event. Or you can say compound event is where you have two events or more than two events altogether. If you take one more example, drawing of a card. Okay, if you take one more example, drawing of a card, and if you are getting a card which is having king, okay, the card of a king, then this king card can be any from the any suit. So now this also becomes a compound event, because it's not only the king card, it can be black or it can be red, or it can be square, diamond, or other two suits. So this is called as the compound event, where in turn it is also occurring multiple events, and that together you call it as the compound event. Okay. Then the next thing is we have sample space. What do you mean by the sample space? Sample space is denoted by capital S. Okay, sample space is the space where, or you can say sample space is the range, or you can say the scope, which covers all the possible outcomes of your experiment. So if it is a random experiment, and then sample space considers all the possible outcomes. Now for example, if your random experiment is rolling of a dice, then what are the possible outcomes we have? You can get 1, a person can get 2 or 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6. These all numbers together defines the sample space of the random experiment of rolling the dice. Okay, so that's the sample space considers all the events or the possible outcomes of the entire random experiment. Now, for example, if you consider tossing of one coin, then what could be the sample space? The sample space could be head and tail. Only these two possible outcomes are there. There cannot be any other possible outcome. So this would be head and tail. That could be the sample space. Now if it is a tossing of two coins, then sample space increases. It can be, so what are the possible four options? If it is two coins, we can have both of them heads. Another option could be both of them tails. Another could be one head and one tail, or you can say one tail and one head, which altogether, okay, the first one is head, second one is tail, or second one is head, first one is tail. Okay, yeah. So there are four such options. So those four options will make the sample space of the random experiment of tossing two coins. If you go for three coins, then this way you need to consider all the possible outcomes of the random experiment. That makes the sample space. So hope you have understood the meaning of sample space. Then the next one is mutually exclusive events and complementary events. Okay. Now these two you need to understand very clearly. Mutually exclusive event means now two or more events. Okay, so now these two are definitions related with multiple events. Alright. So I cannot say this one is the mutually exclusive event. This and this. I mean these 4, 5 events are mutually exclusive events. This way I can say. Now what do you mean by mutually exclusive event? So now if there is one event which is occurring, then that occurrence of one event prevents the occurrence of all other events. Then you can say they are mutually exclusive. Okay, I repeat, if one event is occurring or happening, then the other events cannot happen. It can be either this or this or this. So in this way, when we have the set of events, those events are called as the mutually exclusive events. Okay, so now for example, we'll take the simple example of tossing of one coin. If it is head, then it cannot be tail. Or if it is tail, then it cannot be head. So these two events, that is occurring head and occurring tail, these two events are mutually exclusive events. Because either of one can happen, both of them cannot happen together. Okay, those are called as the mutually exclusive event. Same thing for the rolling of dice. If it is 1, if you roll a dice and if you get 1, then definitely it cannot be 2, 3, 4, 5, 6. None of them it could be. If it is 2, then it cannot be 1, 3, 4, 5, 6. So now these all of these 1, 2, 3, 4, 5, 6, these all are mutually exclusive events because only one of them can occur at once. They cannot occur together. So this is called as the mutually exclusive event. Okay. Now in the case if we consider the other examples, so now for playing cards, if you consider, and if drawing a card from the playing card, and if you are looking for a red one, okay, so now if it is a red one, it cannot be black. Okay, so it is red, either it is red or it is black. So these two events are also called as the mutually exclusive event. Okay, so these are the examples of mutually exclusive events. Now the next concept is complementary events. Now complementary events are those 2 or 3 events or 2 or more events which altogether exhaust all the possible outcomes. So now understand, listen to me well. Those events which altogether exhaust all the possible outcomes of the entire experiment, they are called as the complementary event. Okay. Now, for example, if you consider tossing of head and tossing, okay, when you tossing of one coin, and if you consider the events occurring head and occurring tail. So there are only two possible outcomes when it is a toss of a one coin. And these two possible outcomes, whether it is head or not head. Okay, if it is head, then if it is head, either it is head or it is not head, that means it is tail. So I am just putting it with the different words. So if these two events, it's head or not head, these two events will cover all the events of the random experiment of tossing one coin. Okay, so either head or not head. So then these two events are called as the complementary event. So usually complementary event are like this. One event is occurring and the other one is not occurring. Means one event is like it is head and other one is not head. So these two are the examples. I know not head means it is tail only, but it is head or not tail, not head. Then these two events cover all the possible outcomes of your random experiment, and that's why they are called as complementary event. Okay, so complementary events are those which all together exhaust, or you can say cover, all the possible outcomes of your entire experiment. These are called as a random complementary event. Now for also the example of you can take for rolling of a dice. For rolling of a dice, if you consider that even or not even, occurring of even number or not even. So when you say even number, it covers 2, 4, 6, and when it is say not even, it covers 1, 3, 5. Now these two events, occurring even or not even, all together exhaust all the outcomes of the entire experiment. That's why then these two can be called as the complementary events. So complementary events are this way. Event A is occurring, then event A is not occurring. This way we do it, and then all together they use all the options of the entire experiment. Then only they can be called as the complementary events. Alright, so when you add the outcomes of event and its complementary event, you get the sample space. Well, how do you get the sample space? Because event and its complementary event, both of them are using all the options of the entire experiment, and sample space is nothing but all the outcomes of the entire experiment. So hope you have understood what the meaning of complementary events as well. Okay. Now the next thing is sum of events and product of events. Now suppose there are two events A1, A2. Now what do you mean by sum of events? So now sum of events, it talks about the probability that either A1 or A2 or both of them are occurring. Okay. So that probability we denote it as A1 plus A2. That means either A1 or A2 or both. This way it is. Okay. So that probability we denote by using A1 plus A2 when we are talking about two events. Okay. And product of events, suppose there are two events again A1, A2. Product of events are when A1 and A2 both of them are occurring, then only we can say, then we mention it as A1, A2 together. A1 plus A2 means A1 is occurring or A2 is occurring. But A1, A2 means both of them are occurring at the same time, then we can say A1, A2. Okay. So now A1 and A2 are the simple, those can be simple events or they can be compound events. So now in the case if, in the case suppose if A1 and A2 are mutually exclusive events. Okay. Now what do you mean by mutually exclusive events? If you consider the meaning of mutually exclusive events is what? That either this happens or that. I mean there are events such that, two events such that either one of them will occur, or then only they are called as a mutually exclusive event. So A1 and A2 are mutually exclusive. When do you say they are mutually exclusive? When A1 is occurring and A2 is not occurring. Or you can say A2 is occurring and A1 is not occurring. Then only you can say A1 and A2 are mutually exclusive event. So now what would be the probability for A1, A2 occurring together? So if A1 and A2 are mutually exclusive, So if A1 and A2 are mutually exclusive, then the event A1, A2 cannot occur. Why? Because mutually exclusive event cannot occur together, and if A1 and A2 are mutually exclusive, then A1, A2 is not possible. So hope you have understood the meanings of all these terms. Okay, so the meaning of sample space, meaning of mutually exclusive events, complementary events, sum of events, product of events, and also the first most definitions, that is random experiment, sample event and compound event. Okay, so I think these all things are clear to you. Hope you have understood. Now we'll take few more examples on it. Okay, adding some more examples into it. Now suppose we have tickets numbered from 1 to 20. So there are suppose tickets number from 1 to 20, or there are say coupons number from 1 to 20, and the experiment is drawing one ticket out of it. So it can be any ticket from 1 to 20. Okay. So now in this case, which are the simple events? So the simple events are 1, 2, 3, 4, 5, 6. These all are the simple events from 1 to 20. So if you are getting ticket number 1, it's a simple event. Okay, if you are getting ticket number 2 or getting ticket number one particular number is a simple event. Now what do you mean by compound event? Okay, now compound event is like, now if you suppose if you are looking for a ticket which is multiple of 4, then in that case it is even number. So it is even number ticket you are drawing, so it can be, there are two events that is even numbered as well as the multiple of 4, so it can be a compound event. Okay, then sample space for this would be all the tickets from 1 to 20 would be the sample space. Then mutually exclusive events. Now if it is, we are drawing only one ticket, so if you draw a ticket and we got the number 5, so it can be, when it is 5, then it cannot be 1, 2, 3, 4, 6, 7, 8, 9 till 20. So it can be any one among 1 to 20. So every such event, so altogether this 1 to 20 events are mutually exclusive because they are not occurring at the same time. Only one of them can occur. Okay, so this is called as a mutually exclusive event. And complementary events can be, you can do it this way. Either it is odd or it is not odd. When you say it is odd, it covers 1, 3, 5, 7 till 19. And when you say it is not odd, then it covers 2, 4, 6 till 20. Altogether it covers all the options. So odd or not odd, these two can be complementary event, and they use all the options of the entire, what you say, the entire experiment. Okay. So now we'll have two more examples, which two events we can consider which are not mutually exclusive and which are not complementary events. Again, we'll go back to the same example of playing cards. Okay, we have 4 suits, diamond, square and other 2 suits. Okay, and we have two colors, red and black. Now if you consider two events that it is red, okay, the two events are this way, that drawn card is red, and the second event is that it is the king, the card is king. Now if you consider red and king, so now mutual exclusive events means it can be red or it can be black. So if red card is coming, uh, obviously black is not coming. But which two experiments or which two events were considered, red and king? So there is a chance that it can occur together. So what do you mean by it is also red and it is king? That means it can be king of any which is of red suit. So now red and king, they are coming together. So it is not mutually exclusive event. Mutually exclusive events are those which cannot occur at the same time. Okay, so these two events, like it is a red card and also it is a king card. So these two can happen together. That's why this is not mutually exclusive event. Then whether it is a complementary event. So now red, it covers all the red cards. So out of